Excellent. There we go. So hopefully folks can see my browser. Turn on the chat just so I can see that. Cool. All right. So debugging. So this is one of those. I know Joe. I think Joe and Steph, you both did this, where they presented chapters on things they didn't know that much about to kind of learn more. And this is it for me. Like I am not an expert debugger and don't use all these cool tools. So I was excited to work on this and learn some of this. So we're going to talk about just the super quick general strategies that Hadley suggested for fixing errors. Then looking into the traceback a bit, exploring interactively what's going on, talk a little bit about non-interactive error exploration, and then some non-error issues that come up. So just start off just kind of generally thinking about debugging. I actually like the second quote. Debugging is like being the detective in a crime movie where you're also the murderer. It's not always the case. Sometimes you're on a team of other murderers, but that's kind of a fun thing to think about. So Hadley's kind of very general recommendations were, first of all, to Google, right, just to search for errors when you find them. And he pointed out these two, which I think this is of course like the classic thing, especially when you're teaching folks R. Like step one is teaching them how to Google properly, right? Like how to solve things themselves. And so that's definitely like super important. But he raised these two packages that I hadn't heard of before. Searcher and Errorist, and I just wanted to mention those. Yeah, that's right. Yeah, debugging. Yeah, that's right. I guess detectives like their jobs, right? Finding murderers. So the Searcher package basically just lets you do just like what it says. There's functions that you just type in text inside your search functions, and it goes and searches Google, or it searches Stack Overflow, or it searches lots of different places. You can see the different functions here. You can search Twitter, you can search RStudio Community, right? So it's just a way to kind of interface with directly with your browser to find these kind of other different types of search engines, search GitHub, things like that. So just from the R interface, you can do that. Which I don't know, like I just open my browser and search directly in those pages. So, but maybe that's useful. And actually, where it's useful is where it comes in probably with the second package that the same person produced, which is called Errorist. Which I guess is a play on terrorist. I'm not sure. I guess it's an actual word, one who holds to and propagates error, apparently. But the cool thing about this is when you turn this on, it basically, when you get an error, it automatically opens up a browser with that error in the search in the Google or whatever that you're using. So it just kind of automatically does that for you. So that's, I think, kind of an interesting thing if you want to turn, and you can turn it on and off. Like you can have the browser or have the package running and then turn it on and off if you would like. But that basically that just like super quickly starts you looking up errors if you find errors. So that was kind of interesting thing that I hadn't seen before. So searching is obviously super important. I would also argue maybe, you don't have to use Google. You can use DuckDuckGo. It's another good. If you don't want somebody tracking what you're searching, use DuckDuckGo. Although to be honest, I don't know if the rest of you ever use DuckDuckGo, but if you do, I find probably 80% of the time I can find what I need pretty quickly, but 20% of the time I have to take that search term, and then go put it in Google to get a better search for it. So it kind of depends. But also now, and doesn't show up here, but we have AIs kicking in on some of these searches now. So you start searching for errors, and then all of a sudden you get an AI, not just telling you possible solutions. So that's kind of, I don't know where we're going on that, but I try to turn that stuff off myself at the moment. Okay, make it repeatable. So basically writing your code and clarifying things in a way that's super easy to kind of to work with and repeat some of the issues. Figuring out where it is. Of course, that's mainly what we're focusing here on in this chapter is finding out where it is. And I like this idea of, using the scientific method, which I think we probably all just do by default anyway, right? Generate a hypothesis. So think about where could the error occur, design experiments to test them. So like type some testing, some things out to kind of see if that would support or disconfirm your idea about what's causing the error. But the key thing I thought was interesting here is record your results. Like, and as a scientist, I do this, but as a programmer, I don't. And I was wondering if other folks do this as you're debugging things. Do you like actively record, like write down or somehow track the errors that you're
No,
making? Yeah.
no.
No.
I would like it was I think it was a good call for me because sometimes I forget that, but it's good like to I think writing is like kind of verbalizing your thought, and sometimes my minds go a bit too blank, and I check quickly, but it's half bucket thought. So writing it probably like will structure help me structure on that. So it was a good call for me.
Yeah, I thought the same. It's not something that I've thought about it, but it also makes me think, Hadley wrote this, so is he doing this himself, right? Like, does he have this like all these files and files of notes on errors that he's made and debugging solutions?
I think it depends on the bug. I think
Mm,
if I've got a serious problem that I'm really struggling with, I will write it out because sometimes I need to
yeah.
write out the logic of what's supposed to happen and where I'm going. Because for me, it's almost always a logic problem. Like I've got the logic wrong, but I wouldn't say I normally do it. No.
And do you keep then a log of like strategies for solving the bugs? Like, because that seems like that would be useful, right? Like you fix one bug and that bug
Uh,
doesn't come up again for another 6 or 12 months, and then it comes up again and you've forgotten how to solve it because you didn't have it
It
right down.
depends. I often have like a code design. If I'm writing a package or a project, I'll have a code design script in it. And if there's
Okay.
something kind of particular, like about how I've done things a bit weird, I'll make a note about like, oh, just so you know, this looks like a bug, but it's not for these reasons or something like that. Or if you need to check out these things, like it's kind of because I write things for other people a lot. So I also need to
Hmm.
like, make sure my weird decisions make sense.
No, that's
It's
good.
not quite the same thing, but there are times where a bug will pop up and I'll add stuff to my code design as a result. But bugs are all unique as far as I'm concerned. So it's like, it's if they weren't, then you wouldn't keep making them.
I don't know. That subset closure issue comes up a lot.
Uh,
Yes, yes.
I was gonna say that I never write almost anything, and then I turn left and I remember my post-it. It says like H case that I should always test for a 1-1 matrix because of the drop false. So it's so
That's awesome.
that's my note.
The post-it note, yeah, the post-it note technique. That's awesome. I love it.
No, I think it's a very good advice to try to be I mean,
Systematic, yeah.
yeah, systematic and because sometimes like it's like um I don't know, like you anthropomorphize the computers, which is like like talking to it and say, "Hey, come on, do it." And this is not. I'll just run the same code that was generating an error that should obviously generate the same error. So sometimes it's good like to approach that with a more scientific mind, I guess.
Yeah, no, that's true. And I think actually at the very end there's a link to one of Jenny Bryan's talks on debugging. And actually, one of the things she says is just try it again, right? Like just like you said, like sometimes it's like you feel, you're just banging your head against the wall repeatedly, but sometimes like miraculously things work just trying them a second time. So there's a lot of superstition I find in my coding sometimes. And that
100%.
and that leads, I think, nicely to the next piece too, which is to fix it and then test it. Right. So if you fix a bug, you still want to, go back to those hypotheses and test some other, like temporarily test some things. But that also raises, I think, the point of of the automated tests, which is really useful. And I think this is probably where maybe we all maybe have different strategies because you have different uses for R. Like I know Steffi's doing a lot of package development where automated tests are absolutely critical. Most of my work is just like my own data analysis for the scientific work I'm doing, and I don't use automated tests for that. Like in packages I do, but not for anything like that. But I'm wondering if there's like something in between for folks, some way of building in testing for that, that's not like the full, oops, sorry, the full kind of test that type of system.
I have like my favorite for workflow, especially the ones that are expected to have like data come in, like, and it might be different data next time. It's the advr package, the assert package, because then you can put, especially if you use like pipes, you can just put like verifications in the middle of your pipe that that can be really like, okay, there can't be any missing values, or you have to have these columns, or you can't have more than this, or these values must, like, you can get really creative. It's just essentially if you can ask an if else, or a logical statement about anything in that data, it can be validated inside the pipe. And if it passes, it just goes silently through. And if it doesn't pass, it's like stops your script and like, error, we didn't validate these things. I find that really nice. It's not quite a test, but it makes me feel a lot safer when I'm adding in new data.
No, I think that's a great point at the data validation stage of things. Yeah, using tests and like assertion tests there. That's good.
Yeah, I also use, I'm less a package people, so I just use stop if not and in the script. So it's assertive, but like without the assert package, I just stop if not, like check the number of dimension. And I have seen that also in some package in our open science, by the way. So people like have data package and they just have like literally check the number of dimension that they expect the results is, which I think is a good way of testing data frame. And so I stole that from our open science somewhere. I don't remember where. But yes, I also like, I think most of in my data analysis workflow, there's the null error, obviously, like case where you don't test for NA null and stuff like that, or emptiness, are frequent. The other one is like you can join is probably one of the hardest stuff you can do. And this is definitely where I think why I like the DB and stuff like that, because like you can implement constraints, basically checking like if you have one-to-one relation, one-to-many relation. And that's basically like writing the test before doing it in some way. It's like you enforce it by the logic of the relational database. And it's avoid a lot of error from my experience. But it's not it's not a test. It's like it's a test in some way, because like I'm supposed to have a one-to-one relation or one-to-many relation, and they are defined before.
Right. Yeah. No, that makes sense. I like that.
It's true. Yeah. Anyway.
Yeah. Cool. Good. Okay. So that's just the general strategy. So now let's talk about locating errors. We talked about the notion of a traceback. Talked about that multiple times before. So they just wanted to kind of illustrate that by having a series of functions where you have to kind of go sort that out, find out where the error is, right? You're running function F, but F runs G, G runs H runs I is where the issue is happening. So you can run the traceback, which I think we're probably all familiar with, either with the traceback function or clicking on the show traceback in RStudio. Has anyone tried positron to see if positron has the same kind of? I assume it would, but I haven't tried it myself.
No, I think positron will probably run also depending of what you connect. It's probably, if you use Radian, for example, you will have a traceback with Python stuff. So like, because Radian is Python linting for R, and then like at the top of the bottom of the call, depending how it's structured, I don't remember. So you have like function call to Python, which kind of also like disorient people, because like the R command line you are using is using Radian, not the basic R. So on top of your R, you have like another ecosystem that sends you back the trace code. So it can be messier. I don't know. I'm using VS Code, so it's similar. And then I'm using VS Code and Radian. So sometimes I have like the debugging of Radian also.
Okay. Yeah.
Which, by the way, if it happened to you, I highly encourage to just run a classic R vanilla and see like if so you can rule out some stuff. Yeah. But I don't know. I'm not using positron for now. I should switch. when I get time.
Yeah, they're finally get like some of the more recent versions, I mean, because basically every week there's a new version or two that they're putting out fixing issues, and they're getting better and better. Like some of the issues that I've had are being resolved now with the more recent versions, which is nice. One thing just to keep in mind on traceback is it starts, it's in reverse order. So the bug is first, and then it kind of works its way down the call stack from that way. This is one that I didn't quite get, and I'd actually like if somebody else really understood this a bit more. It'd be great if you kind of mention it, because this is one of the drawbacks of traceback is that it linearizes the call tree, which can be problematic if there's a lot of lazy evaluation. And it gave this example here, which I didn't really kind of see how it illustrated this issue. Does anybody have thoughts or explanations on how this works?
I have not spent enough time on it. I was not very clear what a frame is in that, because like Hadley introduced, like for example, 4 is one of the frame here. If you use like the interactive debugging way, but it's related to me like in Scheme or in other languages. When you have an error, the evaluator return you offer you to return in multiple places where your program is bugging, and I kind of think it at the same way. So you can either abort, let's say like, no, I don't want to debug it, or debug it where like the call stack is in kind of way. So this is how I have understood it, but it's not like I have a good understanding. It's just more like how I feel it is. I don't know if other like have a...
Yeah, I also thought it was a bit confusing because you never see the calls for IH and J.
I think it's
But I guess because they are lazily evaluated, they come from somewhere else and they just end at the same, like right before, well, right in the middle of the F and the, yeah, like like just before the last call. So you kind of get them printed there, although you didn't actually call them there.
I'm not sure I understand much. I think it's because the J is like the argument to F. And so you go into F and you don't evaluate J. And that's why you get this like G, H, I, because they're all being evaluated inside. Like it's like, oh, F passes it. You have to go back almost to look at the previous example so you can see what the F function is, I think. And then you can see the F function calls G, excuse me, the G function calls H, the H function calls I, the I function then does things. And then I think that's where the J function is finally evaluated. So I'm not sure if that's why it's so kind of weird, because then you get finally J at the very end, and then J evaluates K, and then you actually get the stop. So like in a way, I think you'd almost expect that stop to have been evaluated before it went through the stack, because if you evaluate J on its own, like the J open bracket, close bracket, you'll get a stop right away, right? So it's like you're passing an error to a function, but then it goes through the whole tree and then gives you the error at the very, very end. I think that's it. To full disclosure, okay. I read this and I said, oh, whatever, I don't care about this until right now. And then I was like, let's see if I can figure this out. So that's my on the fly interpretation.
And that's always true, right? Like you know, the argument is, this is the title of the slide, lazy evaluation. Like we don't do anything with the argument until we're asked to do something with the argument of the function.
Exactly.
That's been through this whole few weeks, right? Or this whole book club.
And if we changed the if we changed the I function to not actually use the argument it was given, we get no error. But because it doesn't matter that you're passing in an error, if it never gets evaluated, you never get an error. I think that's often why, like they always say, like have your design your functions so they fail early, and I don't know if it's loudly or like clearly. So like, you know, that's why you check your inputs usually right at the top of a function, instead, unless like that's an expensive operation, so that you can get those errors right away. It's not quite the same thing, but anyway.
Good. No, that's helpful. That was really helpful. One thing I'll point out in that section, they talk about the rlang with abort, but that is no longer a function available in rlang, just FYI. So there's an open issue in the book's GitHub site about it, but there's not like doesn't look like there's a super easy replacement for it. So just FYI, if you got super excited about with abort, I'm sorry, too bad, you can't use it. And there's not an easy fix for it at the moment. Okay, so now thinking about the interactive debugger side of things, and this is where the browser function comes in. And so maybe for that, I'll actually just go actually do this. So here's our functions. This is just what we did before. Yeah, here's what happens when you run with abort. It's not an exported object anymore. Okay, so now we can run the browser, and in this case, we're embedding browser into our function. So that's the first thing that happens in our function G. So if we run F on that, it kicks us into the browser. And maybe I know. So Steffi said she uses browser all the time. Or do other folks use this much? Joe, Diana, Olivier, Derek? No, but okay, good. Me neither. So this is good. I'm glad to see. Yeah, so this is hopefully useful for folks to kind of explore. So as we see that, what we see is it kicked us into a new kind of prompt here. Right now we're in the browser prompt instead of in the regular prompt. And so this is where we can start to do various things that they talked about in the in the chapter. And there's, of course, there's keyboard shortcuts for all of these, but there also are buttons here where we can see all of them, right? And there's next, which just executes the next line of code. So one of the things we can see here is we're in the browser, and what that's done up here is it's showing us where we are. The little green arrow in the source document now shows us where we are, and we can use next to click through that, and we can see we've moved down to the next item. And so that's all that next does, is we can keep clicking through that. So you can see when I click the button, it just put an N in here because N is the keyboard shortcut. I think we can also just hit enter and it does the same thing. And that basically, since we were already there, that kicked us out to run the HB. Because we just use next, it just goes ahead and runs that. The next function only steps through the lines in that particular function. And if it calls another function, it doesn't follow into that other function. That's what next does. Another one that we'll see in a second actually does that. So in this case, it then just passes it to H of B, runs H of B, and then gives us, in that case, it gives us the output. Okay, so that's how that works. We can run it. We can run it again. Now we're back in the browser mode just to show these other things I was mentioning. So there's also step into the current function. Let's see, I'm trying to remember what all of these do. Yeah, step. So this one will actually follow us, I believe, into another function. So we can click that. It does the same thing. But now we're at this HB up here on line 26. So if we click it again, now it follows into the H function. And now we can kind of go through there. And that, of course, once this executes, it's going to use I. So if we do that same thing, it should move us to I. And then now it'll step us through each line in I. Right, if we kept doing this at any time, we could do next, and it would, it won't follow into the next function. It'll just, stay in the current function. So I think we're about, that one's basically done there. If we did this again, there's also this execute the remainder of the current function or loop. So this is basically says we're in here, but instead of stepping through, just go ahead and run the rest of this function. So that goes straight to giving us the output here. Same thing. Similar kind of thing here with continue continues execution until the next breakpoint is encountered, which we'll talk a little bit about breakpoints in a moment. And then finally, the last thing, of course, is to stop. So that just gets you out of a browse. If you somehow get yourself accidentally into a browse session, you can do stop, you can do capital Q. Both of those do get you out of there and get you back to a regular terminal prompt. The other thing that you can do is you can make a conditional browse. So in this case, I should look over here at the at the chat. Yeah. Yeah. Good. Always. Okay, so now we're going to create another function G, but now it's conditional, right? So if the input B is less than 0, open up the browser. Otherwise, just go ahead and run HB. So if we run f of 10, that should not open browser because it does not meet the condition. If we do f minus 1, that does. That kicked us into browser. So we can go through and step through just like we did all of those possible things before. This was interesting since we did this before, the f of a, which a causes that error, right? Because it doesn't, yeah, it needs to be a numeric. I wasn't sure what would happen here. Because so I ran that and it runs the function. It doesn't kick into browser mode because the browser is conditional on B being less than 0. And since B is now the character string A, right, that's false. That conditional is false. So it doesn't run us into browser. So it's not that an error causes it to go to browser. It was a particular conditional statement in this case that kicks it to browser. Okay, so that was stepping through some of this, making conditional use of browsers. This goes just as was all of those steps that we just kind of went through. The next step into finish, continue, and stop. Right. So that's basically how we can use browser. Then there's some alternative ways of dealing with these bugs interactively without using browser per se. Breakpoints, recover, and debug. So we'll talk about each of those separately. So first is breakpoint. So this is basically an RStudio specific thing you can set up in your RStudio session. A breakpoint, which means basically this is kind of that's a point it should go to kind of start stepping through things, right? So this part was a little bit confusing to me, so I tried to set some things up a little bit. So here, let's say here's our set of functions, and let's say we wanted to make a breakpoint at the D plus 10. So we just click over here, and that sets up this breakpoint. But what you'll notice is this is an open circle, and it gave us a little warning here. Breakpoints will be activated when this file is sourced. So it's not active right now, even though I clicked on this. It's not active right now. I can't use as a big breakpoint if I run any of these things. Right, there's no breakpoints. It goes straight through everything. And I didn't want to. Yeah.
So clicking to the left of 8, just like in a generic way, isn't going to set a breakpoint, right? Like if I just have a file. So is it just because you've got a particular package loaded, or like did you?
No, this is RStudio. I mean, did you get the red circle?
No, but it's a QMD file, not a .r file.
It probably has to be a function.
Yeah, I think both. It has to be an R. It has to be an R script, and I think it has to be inside a function for that to work.
And then it doesn't even matter if you've loaded particular packages or not.
Yeah, it's not package. This is an RStudio feature rather than a package specific.
Okay.
But this isn't running right now. So I actually, and I don't want to, because it tells us what to do, right? The file hasn't been sourced, but I don't want to source this file because there's a bunch of errors. It's all errors, so it won't work. So I moved it over here to a new file here that I saved. And notice now that it's red. So when I clicked it here, actually, I thought I restarted this so it would be gone. Let's make it, because I've sourced it. Anyway, I've sourced this already. Before it would look like this. Even when there we go. I click it, it looks like that, just like we saw before. But now I can source this this version. Okay, and it does it, right? Like it put us into the browser mode down here. And in a moment, I think if I do this, if I stop. I thought it was supposed to go. When did it go? Okay, there. Now if I click it, it goes full red because I've sourced it once. So now it's an official breakpoint that actually works. So anytime I use F10, oops, sorry. Oh yeah, that kicked me over to where this was for some reason. When I use it, even though this should work, right? Like there's no errors here, but because I have this breakpoint, it basically takes me into the browser so that I can step through it.
I think here it's important to understand, like, well, I mean, a lot of this stuff of debugging interactively from RIPL workflow they were developed to develop sourced files. So you have like an R script and you want to put break, then you source it, then it open the debuggers, which is not necessarily our common workflow.
Yeah, that's true. That's a good point. That's right. This is very specific. I mean, basically the way that I see this is the way to use browser without having to edit your script, right? You don't have to go in and type browser, add browser functions into your script to get it. It's kind of a simpler way to get that functionality without having to edit the script. But you're right. But that is for a particular workflow where you're using R files and you're sourcing those whole files to be able to do it. Good. Okay. So that's the breakpoints, and then there are those few, you can read this, but the troubleshooting that really is about this issue here, which is that you can't actually run this until the file is sourced. That's kind of the key piece for that. So it needs to be a sourceable file, and there's no current conditional breakpoints set up. Next we have another option is recover. And so this is where you basically are setting kind of an option for your session, for your R session, such that whenever you get errors, it gives you this kind of full ability to do something like the browser, basically. So if we go down here, okay, so just as a reminder now, if we have, it's going to bug me. If we run this, we get our error, right? But now if I set the options to error equals recover, okay, now I run that same thing. Now it kind of gets me in something like a browser session, where now it's basically giving me an option unfortunately, I have this since this is sourced, that's causing it to go over there, because that's where let's restart. Restart R. No, it doesn't like me restart. Okay. Restart R. Let's run these. Okay, yeah, we get that error. Now we can set our options to recover. Yeah, so now it's basically says enter where you want to go, right? A frame number, they call it. It gives us the error, but it gives us the ability to start browsing things. So if I want to, I can do 1 to find that, and now it puts us in the browse mode where we can use all of our typical things to step through it. And then 0 gets us out of there. So that's for your session, right? So you can just have that kind of always running, again, without having to go in and insert browser somewhere in your function. And then you just set error equals null to turn that off, so it doesn't kick that out to us. So that's how you turn it on and off. Okay, that's the recover. Next is the debug function, which is, again, similar to this, and Steffi's kind of already alluded to this. Without having to edit your script, you can basically debug one particular function. In fact, I think I don't need the quotes here. So I can debug the I function, and that basically kind of inserts the browser in that first line of that function for us without us kind of seeing it. So now I can run that FA there. And again, instead of just getting the error, I've moved into now the browser where I can go through and step through all of the pieces.
It's definitely feel like it's more like a command line workflow on the terminal.
Sorry, say that again.
It's definitely feel like it was designed for debugging on the terminal in a command line workflow, and not on an IDE. On an IDE workflow where like you have like the script and you are like interactively sending piece of code. It's more, I mean, from my perspective, it feels like you are like SSH it to a terminal, want to debug something, and you are like then using that.
I totally agree with you, Olivier, but like because I don't debug at all and I don't know a ton of programming languages, I don't really understand what other workflow there might be. Like, how would you do this more interactively if it wasn't like script line by line?
Focused, yeah.
I mean, basically, like let's say like you have a script that's running some R stuff in a servers. It's contained in I don't know, a big file name .r. And it's run in some computer elsewhere, and you, for some reasons, let's say like you do not want or do not have time to open you don't, maybe do not even have a text editors. Sometimes it happens. So you are just like, hey, it's broken. So you just first diagnostic is where it's broken. So that's why I feel it was more designed at a time where people were more using common terminal, and people still use that. Like I mean, sometimes even like they are like using NeoVim or Vim, and then they want to have like a way to break on their file. I think this. I mean, that's my understanding of the design of the tool, but maybe I could be wrong.
Right.
Could be. Okay, so we were on debug. So what the debug did then is every time we use the I function, it's going to it basically inserted that browser in the beginning. So every time we run it now, it's going to kick it into the browser mode. So we have to run the undebug I to turn that off so that we get out of. Oh, I'm sorry, I forget. Let's try that again. Undebug. Because I think that worked. Yeah. So to get out of the browser mode there. And that's also where Steffi mentioned there's also, and I took this out of the slides, but there also is the debug once idea, which is like, so instead of inserting it kind of permanently until you turn it off, it just inserts it for the next time that you run it. And then after that, it switches back to not having the browser there. Yeah. And so there's another, and there's a similar thing called set breakpoint, which does the same kind of thing, but instead of for the function, you give it a line number of where exactly you want to put it in a function instead of just at the top. Okay, that's debug. Then moving to the call stack, and this is basically just making the point that you need to know what type of function you're getting access to the call stack with, because that determines what order the call stack is presented in. Traceback, the default kind of version there, starts at the most recent call and then works its way back, whereas most of the other ones, the recover and the rlang functions, last trace and such, do the other way, like they do it in the order that it occurred rather than in the reverse order. So just keep that in mind. And this gets maybe a little bit to what, Olivia, what you were talking about before, which is that all of that was the interactive bugging context, right? The fact that you're there and you can look and see, but there might be cases where you're not in an interactive mode, and so you can't necessarily step through things, but you still want to be able to access aspects of the debugging process. And so one of the things you can do is use this call R function, and basically this builds, so it just lets you build a function and pass arguments to that function in a fresh session, which is nice. What would be like, in theory, this is great because this is like removing all of the environment things, all the variables you have in your environment and the packages that you have loaded and like all of these things, and just runs it, in a new session to make sure that there's none of those things in place. So that, to me, that seems like a useful way of trying to remove all of these other things that could be causing the bugs. That being said, when I tried to use this function, even just like straight up this what they said to do here, I couldn't get it to work. It caused an error. So I don't know what was going on there. So in theory, this seems like a good idea, but I couldn't get it to work in the time I had to try to get it going.
Caller is coming from the package, no? Caller.
Yeah, the call R package, right? So the R function inside the call R package, but it didn't work for me. So that's one way to do it. Helps, deal with aspects of the environment and paths and libraries and things like that. Another one is dump frames, which is basically, like it says, it's a lot like the recover function, but for non-interactive code. So let's go back here. So this way basically says we have this function called dump and quit, which just dumps the frames, all the issues, all the frames for like the recover frames, like we saw before, to a file. And then we can turn that on, so we can run that function, set the option. So now remember, instead of setting the error equals recover like we did before, that's for the interactive way of doing it. This is the non-interactive way of doing it with this function we just created. Now we can do this. In doing that, it just created a new file called last.dump.rda. So we can load that. We can run our debugger, and now that put us into this where we can see those same kinds of things. So it's not interactive, right? We can't go and look up in the script where this happened. It dumped that information to an RDA file, and now this is giving us access to that RDA file to be able to explore some of those things.
Okay, I have a question.
Yeah.
It feels weird to me that there's a function called dump.frames. Okay. But that function doesn't work in the options. That you have to write a second function to call the function. That just feels weird. I don't know. Do you understand my question? Like you had to write the function called dump and quit.
Right.
But there is a function called dump.frames. Like I don't know, that just maybe I'm reading too much into this or something, but I'm not sure why.
Is it because dump and quit's like the hypothetical function that we want to test?
That's not how I interpreted it, but
No?
I could be wrong. Like this.
Do not understand this, so that is not.
Yeah. Yeah, my assumption is I assume that it was that you need also this quit the R session or quit R with
Maybe
error
it's because
status
you also
session.
have the quit. What if you did options error equals dump.frames? And so then it wouldn't quit. Do you understand what I'm saying?
Yeah. Yeah, let's get out of there. Yeah, so now that's giving us the same thing, but I also don't know. Let me go find.
Because maybe the function that you wrote is just expanding it to have the quit part as well.
Yes, I mean I think that's what it's doing. The question. Let me delete my last.dump just to try that again. Yeah, so that doesn't. Damn it. Yeah, so I'm not getting, and it's not creating a last.dump.rda in my directory when I run set the error as dump frames.
I think,
Probably because it's not quitting the session.
I think the example here of dump and quit, if I understand this correctly, is that you don't have to do that. You can just say dump frames, but then the function will continue. And so while you're debugging, you may not want it to continue. So I think the example here is about like kind of creating your own little helper function that you can plop in anywhere, being like after this point, like at this point in the text, or sorry, the code, dump the frames and then quit so I can take a look at everything. Can
you go in terminal and try open the RDA file instead of loading it from R?
In the terminal?
Yeah, and open last dump RDA.
Open?
Yeah, and then last dump RDA, yeah. It did not open anything on your... Oh, it's open in R, okay.
Yeah, another RStudio session that I have open.
Like you had like a default, another default one, because like maybe one of the advantages is like you are like, I don't know what's inside of the RDA file, but maybe it stores a bunch of parameters that maybe you want to have that maybe you do not have in interactive session.
Well, I think this
logging
is when you can't debug interactively, right? When interactiveness is not available to you. So then you dump all the information.
You need to log everything. Like my understanding is dumping the frame is like it's log a bunch of stuff inside of a text file somewhere. And if you just dump frame, maybe you do not have everything. I don't know. Should experiment with it. I was reading it and it's unclear to me.
Yeah. Yeah, same here. This was another one of those more advanced topics for me because this is what I do. I like how they give like start off with all this super hardcore debugging, and then at the end they're like, "Oh yeah, and what if you like want to? I guess
no big
you
deal.
could use print debugging." But I'm like, "Yeah, that's what I do." Like it would have been could be called.
I think like if you can figure out browser, it essentially makes it so that you can be interactive in the middle of a function. And
Yeah.
that is like the most beautiful thing in the world.
Yeah.
I think
No, it is.
print debugging is really helpful to find where you need to put the browser. But once you're in the
Interesting.
browser, like it changed the way I program it. It's so much easier
Yeah.
now.
Yeah. No, it makes sense. Like you're not having to go in and type print, whatever, you know, or cat or whatever. Yeah, the browser is super helpful. But this is definitely where I'm at right now. So
I mean, well, this is how you find out where you need to be.
yeah,
And this is
makes
also
sense.
really great for tests. If you're like, when you can't be, like, I have had so many annoying things where it's like on CI or it's in a test and it only happens when I run the tests like in batch, not when I'm working on it interactively. And so then
Mhm.
I'm like, you know, but so for me, it's like about when I can't, when interactiveness is not an option, this is awesome.
Yeah, that makes sense. Diana, were you going to say something?
Yes, I was gonna say that the last part, that the dump frames part, I understood it like, okay, the first part, the one that says in a batch R process, like if you're in your batch terminal in an SH file and you had to run an R script from an SH file, you will use that to get the frame, to get the dump frame and to make the process quit, because if not, they will just get stuck. And then like later when you open an interactive session, you can like get that dump and use the debugger to actually like see what was wrong.
Got it.
Yeah,
So
see,
you
I
think you could use dump frames here if you're not using a batch session, you're just doing it in the interactive. The dump frame should work here, is what you're saying.
Yes, but like because
But
it's
it doesn't make sense.
inline, yeah, but yeah, it wouldn't make sense.
Yeah, it wouldn't
And
make sense to,
because
but you could do it.
yes,
Yeah,
Got it.
in the help they call it post-mortem debugging, which I find it funny.
Back to that whole murder analogy.
Yeah, back to the old model. Like no, it's basically it. If we stick to this analogy, like basically like the bug has happened, and you want like to go back into the crime to reproduce it, and it's generate the dump, like kind of like, and you revive it with the RDF file. That's how I understand it.
Yeah, that makes
And the
sense.
function here, dump and quick, is just because like we are in an interactive mode and we want a way to generate that in our interactive mode.
Got it.
But yeah,
Okay.
yeah, that's kind of interesting. Like I would like to read bit more about the history of debugging and how people like build stuff around that. It seems interesting to me. But yeah, sadly, the first Google page are a bunch of like, hey, we're gonna help you to debug. I just want to read more about the history of it.
History. Yeah.
Yeah.
Okay, so yeah, print debugging again. That's probably what most of us do, and there's definitely uses for that. The other thing is R Markdown, and this is maybe getting a little bit. So Joe, you were talking about trying to add the shoot. Now I forgot what you called it. The little point pointer. Anyway, in a QMD, and that gets where things get a little bit trickier. And in fact, even if you're in R Markdown, there's like specific ways that you need to be using that you need to interact with debugging kind of systems in R Markdown files, and you have to do some of these other types of error handlers that include calling sync in addition to recover, for example. So there, if you want to do debugging in R Markdown documents, then there's just a little bit extra that you're going to need to kind of think about and work on.
I mean, yeah, just go back to the print. Like there's value also of calling print. Like it's also like you are formulating what the states are changing and printing the states, which is useful sometimes.
Yeah.
It just on the same way like you started by like starting your detective journey. Like it's basically formulating your feeling or whatever your thoughts, and prints help me do that sometimes, I feel.
Yep. No, I think that's a great point. And this is what this shows too, right? Like not just kind of where you can print kind of where you are, in terms of where you're at, how far you get, but also you can print the states of things and see what the values are, so you can see how they change over throughout the function. Good, good. Okay, so that's the non-interactive. So now we can wrap it up with the non-error failures. So other types of failures that you can get that aren't errors specifically. And of course, one is warnings. And often those warnings just get blown by if you're running lots of code, right? You don't necessarily see the warnings that are happening. And so there's ways if you set options warn equals 2, that basically turns warnings into errors. So they'll stop when you get a warning. So just as a way to kind of monitor potential problems that you might not catch since they're not stopping, since they're not errors. They also talked about messages as well. Same thing with messages. And the with abort allowed you to basically do this same kind of thing, but for messages, have it stop for messages. But again, the with abort no longer works, so that solution doesn't work anymore. So it's a little bit trickier to do the messages, stop for messages. Sometimes a function just might never return, so you get a failure because it just never returns what it's expecting. And then it says, which I've experienced multiple times today and working through some of this code for this particular chapter, you just might crash R completely, which won't allow you to interactively debug your code. I didn't realize that basically that suggests that there's a C or C++ code compiled problem. I had no idea that's what that suggested. So that was kind of new to me, that basically now we're talking about situations where some other language is causing problems. And that, of course, makes it really hard to debug when you're trying to debug in a completely separate language. Yeah, so Derek mentions the putting warnings in a different color. And I think that's actually super important to try to get across to students pretty early on, is the difference between an error and a warning and a message. And they treat them all as errors. They come and say, oh, I got this error. I'm like, no, look, your code ran. You got a warning or you got a message. And I think that's important to think about. Yeah, exactly, Safi.
It's super important in the change of mindsets.
Yeah. Yeah.
The color,
I think you're
everything right. And that's something like I was a student also, and when I was doing an error, I thought I was doing something wrong, which is not necessarily the case in a computer language. Like having an error is good. It's basically like the computer is telling you something is or it's expecting it's incorrect, and then you can adapt. What I'm most fearful now is like an error that I do not see.
Yeah,
Like
exactly.
this is something way worse than having an error. Even like a quick one, like usually like the fast error you get is basically because you do something stupid and it can be correct very fast.
Yeah.
But that's in fact good, I think.
Yeah. That's way better than having an error an error in the program, a bug in the program that doesn't trigger an error. So you get the wrong answer, the wrong output. That's definitely way
that's
worse.
hard to teach. Like, I don't know, like,
yeah, that's true. Errors or bugs are good. All right, we'll have to get our entomologists in. Yeah, talk about how good bugs are. Start off. Yeah. All right, so that really wraps it up there. Just a couple of things. This is that talk that I mentioned from Jenny Bryan. If you click on that, you can watch the talk, or you can just get access to the slides to kind of step through those slides. If you haven't seen this before, what they forgot to teach you about R book is pretty good. It's kind of like the next step in your R language after you're pretty familiar with it. I recommend kind of working through this a little bit, and there's some nice kind of intermediate R usage tips there. And then also they suggested Hadley's video on a reprex for Shiny apps. But that's debugging. Yeah, thanks, Joe.
I do. Yeah, no, it was good. Thanks, Jeff. It was super good. I'm gonna type end, but I think really like what matters is not being afraid. Like a bug or an error message, it's not dramatic. Like that's the change of mindset. I think is super important. I don't know like how to teach that, and well, obviously it's always happen Friday evening and stuff like that. So and you have a deadline, and I get it, but like. It shouldn't be like, yeah, I think like I don't know like how to teach that, but I think it's super important to change.
Well, then maybe the murder example isn't the best. for changing mindsets.
I would say like a
Maybe.
bug is still a problem. An error isn't. An error is like information. And
Yeah.
Interesting.
but a bug is still, you don't want bugs in your code because that means what you're doing isn't what you think what you want it to be doing. And so I would say that's still, it's funny, I actually got into like, I'm not sure if it was an argument, it was a discussion that was opinionated with someone about, and they were like, well, you shouldn't tell your students that this is hard. Because like you know, they don't know it's hard until you tell them it's hard. And I was just like, they know it's hard. And they've been like, I can't. And also it is hard. Like I was like, what I tell them is it's okay. You can do hard things. Like you can figure it out. Everything's, you know, hard when you don't know how to do it. Because I don't know if it's the same thing, but I think for me, it's just validating the students. It's like, it's okay. You know, you can find this difficult. It doesn't mean you can't do it. It doesn't mean you won't figure it out. And troubleshooting is part of R. I always say like 80% of R is just figuring out what the error is. And the difference between me and you is that I'm just faster because I've had,
Yes.
you know,
Because
almost 2 decades of figuring it out.
I've had thousands of errors. You've
Yeah,
debugged
exactly. And
thousands.
I recognize them now. I actually, one thing I also do when I teach workshops, especially I get a lot of beginners, like almost exclusively I teach beginners, is I really want to do this. I've been talking about it for years, is to get a bingo card with all the first time errors. Because that way it's just valid. Like, no, we expect this. This is okay. You know, like it's like, see, bing, we got the bingo. You know, like bing, we got the next one. Bing, we got the next one. You know,
that's
like,
a great idea. I love it.
Because then they know it's expected. Maybe that's part of teaching them that it's okay to have these problems because
it's 100% expected. Like and people feel bad about it. Well, they shouldn't, because like we have gone through like tremendous amount of them every day.
And I think also live coding is one thing I've heard too, is that when the students see you make mistakes in your live coding, and then you fix them, and then you're like, oh, does anyone see what the mistake I made? Or, you know, or people will correct you as you go, and then you're like, oh yeah, see, like, you know, it's not that you don't make them, it's just that you recover quickly, or more quickly, I should say, from them. Sometimes you don't. There's actually there's like a Hadley Wickham tweet that I always kind of, I don't know if I have it still, but I use it a lot to kind of, I think I spend like a lot of my teaching time validating students and making them just relax or hoping that they relax. But it was like a tweet from Hadley Wickham, and he's posted a piece of code and said, I spent like 2 hours looking at this and I couldn't figure out what was wrong with it. And it was just like an I versus an L type. It was like a typo, right? And I just really like that because, you know, the students don't know Hadley, but I say, well, you know, ggplot and dplyr that we're using, like he wrote them. He's on the team that made the software. And this is, you know, it still took him 2 hours. So like they get that a bit.
Yeah, but they probably
I got to take off, everybody. Thanks.
Bye, Jeffrey.
See you next week.
See you next week. Have a good weekend.